Good morning. How is everyone doing today? Today, I am going to do a lesson for you on future cities, the Box and Whiskers plot. I think these are really useful. I used to shy away from teaching Box and Whiskers plots, and then when I started digging into them, I found out that they were more useful than I had thought. So they're an important thing for you to know how to do to display data. So again, what we're doing is making Box and Whiskers plots. The essential question is, how can you use a Box and Whiskers plot to describe a data set? We have a set of data. How can I make that so people could look at it and understand? So it's another way of organizing your data. What you're going to learn is how to use Box and Whiskers plots to represent data, how to interpret Box and Whiskers plots, and how to use them to compare data sets. I would also say we're going to learn how to make them. I think a lot of people forget how to make them over time. So I'm going to move this a little bit. Okay. Go ahead and write this down. If you need to, again, pause the video and then pick back up. So here's the core concept on what a Box and Whiskers plot is. Let me make this a little bit bigger for you. There you go. So a Box and Whiskers plot shows the variability. Remember, that is like how widespread out is the data. Okay, so it shows the variability of a data set along a number line. Here's our number line down on the bottom. There are no numbers on this one, but when you make them, you do need to include numbers down here. Using the least value, here's my least value, the greatest value, which is over here, and then the quartiles. The quartiles divide the data set into 4 equal parts. The median, which is Q2, which is right there, and then second quartile divides it down into 2 halves. The median, or the middle of the lower half, is Q1, or quartile 1. Right here is your first quartile. And then I also have Q3, which divides the upper half of the data in half. So remember, we talked about this when we had the 5-number summary. We have the minimum, Q1, Q2, Q3, and the maximum. So go ahead, write this down, pause if you need to, and then continue on. So we're actually going to make a Box and Whisker graph, make a plot, make a Box and Whiskers plot that represent the ages of the members of a backpacking expedition in the mountains. So here's a group of people who went into the mountains. There was a survey asking them what their age was. Here are the answers. So the steps for doing this are put the data in order. So put all the ages in order. Find the middle. That's the median, Q2. Find the middle of the lower half. Find the middle of the upper half, find the smallest and the biggest. So 5-number summary. Here is your data again. So go ahead and pause me if you need to. Find the 5-number summary, make the Box and Whiskers plot, and then come back to where we are. So again, this is how you find the 5-number summary. And here is it all put together for you. So when I put them in order, 18 is my lowest. I'm going to put a dot on 18. And notice how they did add numbers to this number line. So I can tell 18, 19, here they're counting by ones. You don't have to count by ones. It just makes sense in this problem. You could count by 2s or 5s or 10s or whatever works for your problem. So I put them in order. I'm going to put a dot for the smallest, a dot for the biggest, so that's my max. Here's my min. Then I find the middle number. The middle number would be 25. And when I find the middle of the lower half, which is 23, again, I'm going to average these two together. Remember, if it's an even number, I add them together and divide it by 2. Here is the middle number of my upper half. So Q1, I'm going to draw a vertical line right here for 23. I'm going to draw another vertical line at 29. I draw a vertical line at 25, and then I just construct my rectangle around it. So how did you do on this? Again, things that are important to do is put numbers on your number line, 5-number summary, and then draw it out from there. Notice what they did is they actually put dots for all the 5-number summaries, and then they just either left them as a dot for the tail over here, or they made a vertical line to make their box. So here's one for you to practice. Basketball player scores 14, 16, 25, 22, 30, 16, and 28 points during a tournament. I guess on day 5, he didn't get to play very long. Make a box and whisker plot that represents this data. Again, I told you to go ahead and make the 5-number summary first. You're going to put those on a number line, decide what you want to count by, and then go ahead and construct your box and whiskers plot. And, oh, that was the answer. Sorry, I was getting confused on to what I was doing. So here is the box and whiskers plot. Here's his lowest score, which was 5. His biggest score, which was, when I look at the data, it is 30. And then here is Q1, Q2, and Q3. I hope yours looked exactly like that. If not, figure out what you did wrong, fix it. And if you have questions, make sure you ask Ms. Lofts or myself. Interpreting a box and whiskers plot. So not only are we going to learn how to make them, we're going to learn how to read them. So the interesting thing is that since I divide the data, once I put it in order, I divide it in half and then half again. I have it arranged in fourths. So notice that 1/4 of the data is in this whisker out here. A total of half the data is in the box. But remember, 1/4 of it is really down here between Q1 and Q2. Another 1/4 of it's between 2Q and Q3. So when I add that together, I get half out here. And then I have another 1/4 of it in this whisker. A measure of variation of a data set is the IQR, the interquartile range, which represents the difference of the 3rd quartile and the 1st. It is the range of this middle half of data. So a lot of times people talk about the IQR. IQR is Q3 minus Q1. Interpreting a box and whisker plot. The box and whisker plot represents the length in seconds of the songs played in a rock band at a concert. So here's the range of them. Here's all the data. Find and interpret the range. Describe the distribution. Find and interpret the interquartile range of the data. Is the data more spread out below Q1 or above Q3? Explain. So let's think about it. What would I know about the range? How would I even find the range? Remember the words symmetric, skewed right, skewed left. Do you think this is symmetric? And then the interquartile range is going to be Q3, which is right here, minus Q1. And are they more spread out? So is this tail longer on the left or is the right one longer? Let's look at the answers to those. So the least value is 160. The greatest is 300. So the range is 300 minus 160 or 140. That means the song lengths vary by no more than 140 seconds. Each whisker represents 25% of the data. The box represents 50% of the data, and we talked about that before. If I look at it again, 25% of the data is in the left whisker, 25 in this whisker on the right. 50% of the data is actually in my box. So 25% of the song lengths are between 160 and 220 seconds. 50% of the songs are between 220 and 280. 25% are between 280 and 300. IQR, Q3 minus Q1 is 280 minus 220, so that is 60 seconds. That IQR is 60 seconds. This means that just the middle half of the songs, the half that are in the box, vary by no more than 60 seconds. And when I look back at my box and whisker plot again, this left whisker is much longer. So the data on that left-hand side are more spread out. So the data below Q1 is more spread out than above Q3. Here's another one for you to try. And this is about age. This is the one, I put it here for you to see it. It says, use the box and whisker plot in example 1. Here it is right here. Find and interpret the range and the IQR. Remember, the range is the max minus the min. IQR is Q3 minus Q1. Describe the distribution. So go ahead and pause, answer those questions, and then come back. The range is 30 minus 18, or 12 years. This means that the ages vary no more than 12 years. IQR, Q3 minus Q1 is 29 minus 23, which is 6. So the interquartile range is 6 years. The middle half of the ages vary by no more than 6 years. Now, when I look at box and whiskers plots, I can talk about them being symmetrical. I could talk about them being skewed left or skewed right. Just like when we did the histograms, symmetric means that it is roughly even on both sides of Q2. If I fold it in half, the halves are going to match. This means that the median is the middle of the plot. Skewed left means my tail is pulled out here to the left. So my left whisker is longer than my right whisker. Most of the data are on the right-hand side. So if I drew a line down half of this, you notice that most of the data is over here on the right. That is when it's skewed left. Skewed right, the whisker on the right is much longer. Most of the data are on the left side. So again, the middle would be right about here. And notice how much of my data is to the left. So when I'm skewed right, my data is on the left. Comparing box and whiskers plots. This is a double box and whiskers plot. So again, this is like a double histogram when I just put two similar sets of information on the same number line. So this is my class in blue, my friend's class in red. So the double box and whiskers plot represents the test scores for my class versus the test scores for my friend's class. Identify the shape of each. So are they symmetric? Are they skewed? And if they're skewed, are they skewed left or right? Which test scores are more spread out? Explain. And again, go ahead and pause, write down your answers, and then hit play again. So for my class, the left whisker is much longer than the right. Most of the data is on the right. For my friend's class, the whisker lengths are equal and the median is in the middle. The distribution for my class is skewed left. This tail is much longer over here. The distribution for my friend's class is symmetric. The range and the IQR of the test scores for my friend's class are greater than the range in the IQR from my class. So the test scores of my friend's class are more spread out. Okay, here's another one, very similar. Double box and whisker plots shows surfboard prices at shop A and shop B. Identify the shape of distribution. Which shops' prices are more spread out, and explain. That means you're going to write a sentence and tell me which one has more spread out prices. When you're ready, you can just continue on. So for both shops, the right whisker is longer than the left whisker. Most of the data are on the left. So both distributions are skewed to the right. The data is pulled out on the right. The range and IQR of the prices in shop A are greater than the range in IQR in shop B. So the surfboard shop prices are more spread out in A. How'd you do on that one? And this may be the last one that I have. It is. So if you need to review this again, go ahead and do so. Hopefully this will help you make your own ones. And you're done with Box and Whiskers, and I'll see you in a future video. Hope all is going